Good morning, everyone.
Good morning.
Good morning. I hope everything will go well today. Last class, like we had so much internet fluctuation. All right. So we have 16 students. So let's wait for another 1 or 2 minutes and then we can start. So I will go over what we did in the last class. We will talk about conditional probability and Bayes' rule. And as we discussed in the last class, I extended your homework and quiz. So your homework is not due today, it's due tomorrow, and your quiz is due on 19th. So you have an extra day for homework and 2 extra days for the quiz. So make sure take advantage of that and go over all your concepts and then work on that assignment. So your homework is due tomorrow. Make sure you work on that so that if we have questions on the homework, we can work on those questions on Friday's class. And quiz is due on Friday, so I will not be able to take the quiz questions in the class. But if you attempted the quiz and you have questions about any of the concept or any of the questions in the quiz, feel free to send me an email and I'll go over with that problem with you. So let's start our today's session. Last time we talked about conditional probability. And first of all, I want to ask, anyone has any specific questions? And you guys can hear me?
Yes, we can hear you.
Okay, thank you. Just want to make sure. Last time it was a mess. So let me start with conditional probability concept all over again. And please stop me if something is not making sense to you. So what is actually conditional probability, or what is the concept of conditional probability that we are using here? So when we say conditional probability, we are looking for the probability of an event under a specific condition. So if we are looking for the probability of an event, and let's say we have two events A and B, and we are looking for the probability of A, and we know that event B has already happened. So we are looking for the probability of A under the condition, or you can say under the given condition that B has already happened. So if we have two events A and B, and we know that B has already happened, or we are looking at the probability of A under the condition that B was already done, and this B is going to affect my chance of A. So if I'm talking about this is my intersection, right? So I'm looking at the probability of that part of A which is contained in B. So what is the probability of this part over this whole? So that's what we are looking for. So probability of A given B, this symbol we use is, that's how we say given. So A given B. So that means B is already happened and we are looking for the probability of A, this part inside this. How this change when I know that the probability of B will affect my A. So probability of B, because it is given, so I'll divide with the given probability. And then this part, we are looking for probability of A, which is in B. So that means the intersection of A and B. And again, probability of B should be greater than 0. So this is what conditional probability is. So we are looking for the probability of any event under the given probability of other event. So if I'm talking about B and B has already happened and it's going to change my chances of A, then how much or what are those chances, or what is the probability of that A when I know the probability of B. If B is not changing anything, then I don't have to look for the conditional probability. Then those two events are called independent events. So those two events, or you can say two events, are independent if knowing the chance of one is not going to affect the chance of other. Or let's say this, knowing the chance of this is not going to change anything for this. So those two events are said to be independent. So for independent, we know their conditional probability is the product of these two. So this is what we know for the multiplication rule for two events. And if these two events are independent, that means their intersection. So if two events are independent, they're not going to affect the chance of other. So if we are talking about the conditional probability, but at the same time we have more information that these two events are independent. So this is the formula that we use for conditional probability. But when we know that these events are independent, if they are independent, they're not going to affect each other. If they're not going to affect each other, if the probability of B is given to me or B is not given to me, it's not going to affect. So let's plug this value here and we get probability of A given B is the product of these two divided with, and since we have this common, this is just the probability of A. So conditional probability of A given B is just the probability of A, and think it that way. If we are talking about two events A and B and both events are independent, if they are independent, even if I know the probability of B or not, it's not going to change my probability of A. So it will stay the same. So this is when we are talking about conditional probability of independent events. So when we are talking about conditional probability of independent events, you don't have to do a lot of math or anything. Just look what is the probability of A. That is the probability of this. So this is the rule for conditional probability for independent events. And this is the rule for conditional probability of general events. So that's what we did in the last class about conditional probability. So we use a conditional probability formula for independent events, and we can also use this formula to make another rule, or you can call it as multiplication rule for conditional probability using the same formula. A given B is their common part divided with the given probability. So in case I know this and I know this, but I don't know the intersection, then how do I solve? Then I just multiply these two. And this will give me the multiplication rule. Probability of A intersection B, this part, is the product of these two. Probability of B times A given B. And if I write A intersection B or B intersection A, it is the same thing. This part is also called as A intersection B and B intersection A. It is the same thing. So I can either write A intersection B or B intersection A. So this rule is also applicable if A is given. If A is given, then you can write it. B given A. And again, here B is given, so probability of B is greater than 0. So these are called your multiplication rule for conditional probability. And again, we don't need to memorize this. If we know the conditional probability rule, this rule comes from there. So if we know these two things, we can find this. And why do we need to find the intersection? If we are talking about general addition rule, and the general addition rule that we work with, probability of A union B is this. And to find the intersection, the problem gives you the probability of B. Of course, you have it here. And it also gives you probability of A given B. Then you can find the intersection by multiplying and replace it here. And you have questions in your homework assignment where you have to do that part. So this is one thing that I want to make sure that you understand the logic of conditional probability, looking at the probability of one event under the given condition. So how that given probability will affect my other events probability. So that is the topic or the concept or the logic behind conditional probability. Now questions. Anyone has any questions for me? Okay, if not, let's see the tree diagram and see how we use conditional probability or how do we do the notations. So we will do the problem later on. First, let's just look at this tree diagram. And as I mentioned in the class, that tree diagram helps us to understand what information is given to us, and we can visualize that and assign the probability to each part or the given part or the intersection. So tree diagram help us in understanding a lot of things. But again, you don't have to work with the tree diagram. You can use table also. Or if the table is given, you want to work with the tree diagram, you can make your tree diagram and work with that. In your homework assignment, there are two questions. I think it's question number 18 and 19, and the tables are given to you. You can work with the table or you can make the tree diagram. And if we have time towards the end of this class, I will go over question number 17, 18, and 19. And if I forget, to remind me around 11:30ish, and I will go over with that. So let's see first, this is the tree diagram. How do we interpret this tree diagram? We discussed it in the last class, but last class we had so many internet issues, so I'm going over everything again. So as we look at this tree diagram, it says that a randomly teenager, and let's just read what information we have. It says that an Internet and American Life project finds that 93% of the teenagers use internet and 55% of the online teens have posted a profile on social networking site. And this tree diagram we made on the information that is given to us. So 93% of them are online. So this is the probability of online or using the internet. And since the sum of these, and since it's a tree diagram, we have two branches. One is with online and without online. Without online is 1 minus this. So not online. And if it's not given, we can subtract this from 1 and we get this part. Now, on the first branch, you have sub-branches. So if the students or the teenagers are online, they uploaded their profile, and the probability of that is 55%. And again, you see that everything is converted into decimals because we are looking for a sum of 1. So if the percentages are given to you, convert into decimal first. So how do we write this 55%? What is this in probability notation? Anyone wants to try, guess? So it says that a teenager posted the profile when they are online. So what is given to us? How can they posted the profile? So we know that they are online. This information is given to us. So probability that the teenagers are online is given to us. And posted the profile. So what is given? Given that they are online and then they posted. So this is the probability of 0.55. Now, if the question is asking what is the probability of online and posted the profile. So if the word is saying and, we know that we are talking about intersection. And when we talk about the intersection, that means we are looking for probability of online intersection profile. And if you look, we have the conditional probability, we have the individual probability. Can we find the intersection part? And the answer is yes. We can use our multiplication rule. But let's just see what we have done. So I'm just writing the formula that we use for conditional probability. A intersection B, right? And now let's see what my A is, what my B is. So given that it's online, probability of what is my A? The probability that the students are online. No, the students posted a profile given that they are online. So this is my this part. And this is probability of posting a profile and they are online. And B is my online. So I just use the same formula and see what is given to me in the question. According to that, I plug that profile given online. A is my profile, B is online, and then I plug in the formula. Now I will go back to the question and see what my question is asking. The question is asking what is the probability that teens are online and have profile. So the question is asking me this part. I need to solve this part. To solve this part, I need to know this and I need to know this. So I know that probability of A intersection B, which is this part, is the product of these two. Probability of B times probability of A given B. Same thing, we can do that. We have this information and we have this information. So we can say that probability of profile intersection online is the product of probability of online times probability of profile times online. And you have this information, probability of online is given to us as 93%. This is your 93% and this is your 55%, and you can solve it. And if you look at this example now, that's exactly how they solve. Probability of online is this, profile given online is this, and then you multiply both. And once you multiply, then convert back into percentages. So you times by 100 in percentage, and that gives you your 51.15%. Now questions. Anyone has any questions on that? Is the concept making sense now?
Yes, can you go back to the thing you wrote up? Yes, thank you.
Anyone has any questions? So there are questions in your homework and quiz on conditional probability. So make sure what information you have. Out of these three, you have this, this, or this. Whatever you have two information, you can find the third one. And again, conditional probability tells you the probability of an event under the specific condition of the second event. So let's talk about the Bayes rule. Last time I said that Bayes rule is an important application of your conditional probability. So you can think of Bayes rule as an extension to conditional probability. We are doing the conditional probability, but at the same time, we are looking for more in the denominator. So this is the denominator that we use here is just the denominator of one of this, but now we are looking for more. So when we are talking about Bayes rule, let me just go over with this here instead of using the slide. In the slide also they explain it, but they did not derive the formula. They gave you the formula as it is. And if you want, I can upload that on Canvas also. So Bayes rule is an important application of conditional probability, as I was telling, and it helps us to understand a lot of different problems. And if you do higher level statistic course, you will use Bayes rule. So as we did in the last class, suppose that a sample space is decomposed into k disjoint events. So that means I have a sample space, and in the sample space there are k events, and k means I don't know how many, 1, 2, 3, 4, 5, 10. That k is any number. K is 1 to n, any events. So when we are talking about k disjoint event, again, the word disjoint says that these events have nothing in overlap. So they are non-overlapping events. So we take a sample space, and this is my sample space, and I know that the probability of this whole sample space is 1, and I divide into k disjoint events. So this is my A1, this is my A2, this is my AK. So this is what it says. And when you look at the probability of A1, probability of A2, probability of AK, it is 1. So when we divide into sum events, and that sum is k can be any number, 5, 7, 9, 11, 13, any number. So when we divide a sample space into multiple disjoint events, the sum of the probability of all the events adds up to 1. Now we have another event C that is intersecting all my disjoint events. So let C be any other event such that PC is not 0 or the probability of C is not 0. So again, the probability of this is greater than 0. So now if we are saying we have another event that is intersecting all of my events, and if I'm calculating the probability of this C is this plus this plus this plus this plus this plus this. So this C is not just one, it is a sum of all of these. If it is the sum of all of these, that means I need to find what this is. And when I look at this is the intersection of A1 and C. The common part between C and A1 is this. So it is probability of A1 intersection C. This is probability of A2 intersection C. And then you keep on going until probability of AK intersection C. So this is the probability of C. So when you look at your previous example of conditional probability, when we were looking at the denominator, we just wrote one value. But now we have to calculate this C because this C is intersecting all of them. So that is the extra part that we are doing in Bayes' rule. So then probability of C is this that I just explained. And from conditional probability, we know that probability of C given AI. So I'm looking at probability of C given AI. AI can be A1, A2, A3. So I used I. So I is from 1 to K. The value of I varies. It can be 1, 2, 3. As long as I know the probability of C, I can find the probability of A1 given C, A2 given C. But again, first I need to see what is the probability of C given AI. And that AI can be A1, A2, A3. This is your conditional probability formula. So we are looking for C given AI, probability of C intersection AI over AI, just the probability, conditional probability rule or formula that we just derived. And this one is your multiplication rule. You multiply these two, and then you get this value. Questions up till here? Anyone has any question? So this is what we have done in conditional probability, and this is we just did we just look at the probability of C, which is intersecting all the events, all the disjoint events. Now we need to find the probability of C or the probability of AI given C. AI, A1 given C, A2 given C, AK given C. So how do we do that? Same probability, conditional probability formula, intersection divide with C. And I know what my probability of C is this part. So this whole thing will go here in the denominator. And what is this? Probability of AI intersection C. Can I replace this part here? Because C intersection AI or A intersection C is the same thing. So using 1 and 2 in this equation, it becomes this. So I have not done anything different. I just derived this probability of C, and I derived the probability of AI intersection C using your multiplication rule. And this is what we get, probability of AI given C. And again, I'm mentioning AI. I can be, when you look at this, A1, A2. So I can be 1 if I'm just looking for the probability of 2 with C or 3 with C. So this I will be replaced with wherever you have that in the question. So once you have this part, you know that A1 intersection C, and we have just done it here. So it is, if I put 1 here instead of I, it's probability of A1 times probability of C given A1. So that is replaced here, here, and up till AK. So finally, the Bayes rule or the probability for AI given C is the product of these and the summation of these. So denominator is not just the individual probability. Now it is the sum of all the probabilities of the intersection, because this is the sum of all this. So now you're finding this part and you need to look for these individual intersection. And according to the rule, we know that intersection of B is probability of B. If B is given, then it's this. And if A is given, then it's B given A. So that's what you're doing for 1, 2, 3, and all. So this is your Bayes rule. So Bayes rule, again, AI given C. If A is 1, how do we write this? A1 given C is probability of A1, because my I is 1, probability of C given A1. And this is the sum of all. So this is probability of A1 given. So same thing comes here on the numerator and denominator, but denominator is the sum of all the K events. So you'll just keep on going until so that is your Bayes rule. And again, the formulas does not make sense until we plug some numbers to it and see how to apply that rule. So I'll go back and do the example from your slide. If anyone has any questions for me, just let me know. So this is what your Bayes rule says. And again, Bayes rule, if you apply the formula, sometimes the formula is little complicated. And if you use the tree diagram is more easier to understand and see what information is given. But you are free to use either the formula, tree diagram, table, whatever makes sense to you or easy to understand. So let's do this example. We have done that in the last class, but we were in a hurry. So let's spend some time on this and then do example. And one more thing I want to ask you guys, your test is scheduled on Monday. And we have only one class between Monday and now for your review. Do you guys want to extend the test to Wednesday instead or keep it on Monday?
Yes, please.
Wednesdays.
Please.
Yes, please.
So
Yeah,
Wednesday
be
is
helpful.
better? Okay. So what we will do, like today's class, again, it was supposed to be a review class for chapter 3, but since last class was a little messy with that internet and all, and this concept is very important. So we thought going over this concept in this class. So next Friday, we will do chapter 3 review. And on Monday, we will do the review for chapter 4, and then your test will be on Wednesday. And I'll send an email regarding that also, or Ms. Minion will send. So you know that, or if somebody's not attending the class today, they'll know that the test is moved to Wednesday.
What would be the time frame for the test on Wednesday?
So again, it will be the same. It will open 10 o'clock. And what was the time last time? It was till 2 or 3 o'clock? Or what I think I opened. So at least you will have the time frame for during your class time. We will not have class that day. So maybe I'll open it for 5 or 6 hours. I will discuss it with Ms. Minion, and we will send an email so you know what will be the time frame. But definitely your class time, if you do not have any other time, you will have your class time to work on the test.
Thank you.
You're welcome. So let's talk about this example. So in this example, we say that if a woman in her 20s gets screened for breast cancer and receive a positive test, what is the probability that she does not have a breast cancer? So again, when we do for the testing for certain diseases, those testing are not 100% accurate. Again, in chapter 6 and 7, we will talk about how much is the room for error. So sometimes they said that it's 97% accurate, sometimes it says that 99% accurate or 95% accurate. So let's say you go for, or I go for the testing and I don't have a disease, but in the test, it comes out that there is a disease. Or if I have a disease and I do the testing, and in the testing, it can come out that there is no disease. So the chances are both. Or if I have a disease and the test detect that there is a disease, or I don't have a disease and the test detect do not have a disease. So we get 4 answers, or we get 4 results when we go for testing. And these results are denoted with different things or with different names. So if there is a disease and the test come out positive, we call it as the sensitivity of the test. So there is a disease and tests come out positive. So how do we write? Tests come out positive, knowing that there is a disease, right? So if that is the case, tests come out positive, there is a disease. Given there is a disease, tests come out positive. So we are talking about sensitivity of the test. If there is a disease, but there are chances, and the chances are very low because, again, if the test is used to determine if there is a disease, there are more chances to detect it. But still, there are few chances that the disease cannot be detected. And let's say here it's given as 2%. So if, or 20%, so 20% chances that the test is negative. So this, if there is, the tests come out to be negative, but there is a disease. So we call it as false negative, as you see it here. So this is called as false negative. So there is no disease, but the test says that, there is a disease, but the test said that negative results. Same thing, if you do not have a disease, you go for a testing and they said, oh, you have a disease. So again, actually no disease, given that there is no disease. So let me say D complement, given that there is no disease, but the tests come out to be positive. And that is called your false positive. And if there is no disease and tests come out negative, which is a correct test, then we call it as the specificity of the test. So sometime in the problem, they give you specificity of the test, or false positive is this, or false negative is this. Again, in your homework assignment, there are no questions like that, but you can see that if you are working on Bayes rule in other, let's say in some examples. So you will see that the word specificity, sensitivity, false positive, false negative, then you need to see what is this false positive means, what information, or this value means what. So this value means this. So this is one thing. The second thing, as I mentioned, how do we read or how do we write these values in the probability notation? So when we look at the Bayes rule, or the tree diagram, let's say, it says that there is a disease and there is no disease. There are 2 branches, one with the disease, one with the non-disease. And the probability of the disease is given to us, which is 0.0004. If we know this part, we can calculate this. If it's not given, you just subtract from 1 and you get this. The sum of these 2 branches should add up to 1 whole. So first part done. So how do we write these in probability notation? So this is the probability of disease. So instead of cancer, I'm just writing disease. So probability of disease is this, and probability of no disease is this. If the question is asking you just this part, you're done. If the question is asking you, what is the probability that there is a disease and the test is positive, or the given that the test is negative? So let's look when is the test positive with the disease. So when we are looking at this, the test is positive, but I don't know until I know that there is a disease or no disease. So this part is given to me. So probability that there is a disease and the tests come out to be positive. And this is this probability. So positive, test is positive, we know that. But when given that there is a disease. So this is the probability of test coming out positive when there is a disease. Similarly, can you tell me how will we write this part? What is this 20%? What is given to us?
Probability of a false negative given there's a disease.
Or positive, a probability of false negative, or you can say that there is a disease and test is negative. That is the probability of this. Similarly, this one, false positive, is what? Probability of positive test given that there is no disease. And probability of negative test given that there is no disease. So now you have all the probabilities, or you have the notation of the probability for all. And now if I need to look at what is the probability of test coming out positive. So I need to go back to my tree diagram and see in how many cases the test is coming out to be positive. The test is coming out to be positive here and here. So if the question is just asking what is the probability that the test coming out to be positive, like how we did, what is the probability of C? So no matter what event we are talking about. So here we are saying what is the probability of test coming out positive, no matter if there is a disease or not a disease. So we are just talking about these two things, right? The test can come out positive here and here. So when we are looking for the probability of test coming out positive, again, we are looking for the cases where the test is coming out positive. So it is the product of these two and these two. So test coming out positive is the probability of D intersection the test coming out positive. What you can say, test coming out positive is the probability that there is a disease, and then test coming out positive, and there is no disease but test coming out positive, right? So test can come out positive, and again this means positive. So test can come out positive in two cases, either here or here. Same thing if we are looking test coming out negative, negative is also coming out in two cases. But if the question is asking specifically what is the probability test coming out positive given that there is a disease, then it's only this part. This is the only thing given that there is disease. This one is given that there is no disease. So now let's go back to the question and see what our question is asking. It is asking what is the probability that she does have the disease. So receive a positive test. So given that the test is positive and she has the disease, so we are looking for this part. So it says that if a woman is screened and receive a positive test, receive a positive test, that means given that the test is positive, what is the probability that she does have the disease? So we are looking for this part. And when we are looking for this part, let's first write, how do we write this in the notation of probability or conditional probability? Given that there is a disease and the tests come out to be positive, is the intersection of disease and positive divided with the tests come out to be positive. This is our conditional probability rule, right? A given B is A intersection B divided with the probability of B. And now, what is probability of test coming positive is this. And we know how to calculate the intersection. Intersection is, again, we are using the formula for the intersection is this one. It is the multiplication of these two. And the multiplication of these two is this times this. And let me.
Professor Goal. So for the answer for that one, is that the 0.3 or would it be 0.8%?
This one?
For the question that was asked.
This one you were asking, sorry, I didn't get your question. Are you asking about the answer in the end or?
Yeah. So would it be the 0.3 or would it be the 0.8? Because I was just a little bit confused since it said if she did have cancer. So I thought it would just be the branch that just had cancer.
So if she, and it also says that receive a positive test. So given that the test is positive and she has a disease, so you need to look for how many cases the test comes out to be positive.
Okay. So it can be positive and then false positive.
Yes. So it can be positive and false positive. So that's the extra part we are doing it now. So now we have the given probability, and that it's not saying just that the test is positive, given that there is a disease. It's just saying that what is the probability that the test comes out to be positive and she has a disease. So
Okay.
when we are looking for the disease, and again, when you look at this one, I think I mentioned last time also, there is a typo. This is 0.0004, because if you use this, you will get a different answer. Here, it's after decimal, there are 3 zeros. So this is given that the disease and the test is positive, is this, the intersection. And again, we know that intersection is the product. So if I'm looking for, if I know this and this, intersection is the product of these two. And same thing, the denominator is this one, positive test. Where is the test coming out positive? Here and here. And same thing, the question can ask you, given that the test is negative, what is the probability that she does not have a disease or she has a disease? Then if given that the test is negative, we need to find this probability. And then what is given? Negative, but then what I'm looking, if she has a disease or she does not have a disease. So that is a Bayes rule. Questions? I hope this time it makes sense. And let me quickly go over your practice problems. Let's see, where do I have the practice problems? Nope. I uploaded those. All right. All right, so I don't see where I uploaded the practice problems. So let me just go over your homework problems that I just said that about the conditional probability and Bayes rule. So look at question number 17. Some of you have already worked on this problem. Some of you are still working on it. So I just want to make sure that you understand what actually the question is asking. And sometimes reading the information, or you can say reading the word problem, is a little complicated comparatively to this problem, like where you have all the information given and you need to just plug the values and solve it. So let's look at this. It says that, and again, the practice problems are uploaded on your Canvas. Work on those, and we will upload the solutions for those problems. You need, and I think you don't need to do all. After the class, I will send an email where I specify what problems you need to try. So this one, question number 17, it says that Bob has recently been hired by a shop downtown to help customers with various computer-related problems. Lately, 2 different viruses have been bugging many customers, and there are 2 viruses. One is Dummy and one is Smarty. It is estimated that about 65% of the customers with the virus problems are bothered by Dummy, and the remaining 35% are with the other virus. If the computer is infected by Dummy, Bob has 90% chances of fixing the problem. And if it is infected with the other virus, Smarty, it has 70% chances of fixing the problem. So this information is given, and we can use this information, or we can make a tree diagram or a table to see what information we have. Now let's see what the question is asking. A virus infected computer is randomly selected from the shop. What is the probability that it is infected with dummy and cannot be fixed? And if you look at this question, this is exactly similar what we just did in the example on your slide. So let's see how to make a tree diagram first. So it says there are two kind of viruses. So let's work on that. So one is your dummy and one is your smarty. And it says that it is estimated that 65% of the customers are infected with dummy, and the remaining 35. When I add this, I will get one whole. And it says that if it is infected with dummy, Bob can fix it. Bob can fix, and let's say not fixed. And the chances are 90% that he can fix, and 10% it cannot be fixed. And if it is infected with Smarty, Bob has 70% chances of fixing and 30% chances of not fixing. Now you have a tree diagram, you have all the probabilities. You can use them in the notation form. This is the probability of dummy. This is the probability of Smarty. What is this? So probability of fixing, given that when it is dummy. Probability of not fixing when this. Same thing, probability of fixing the virus when the virus is Smarty and this. Now you have all this information. Go back to your question and see what the question is asking. It says, what is the probability that it is infected with dummy and cannot be fixed? Infected with dummy and cannot be fixed. So you know that it is infected with what kind of, given that it is a dummy virus and it cannot be fixed. So make sure you know what goes here, plug it, you have all the information, and then you can solve it. So hope this tree diagram makes sense. Does that make sense? So first you need to look for the probability of not fixing. So under what case it is not fixed. So work with that. And once you know the probability of not fixing, then you can find that it is not fixed and it is infected with dummy. So I hope you understand what goes here inside, what is given to you. So first find that given probability, not fixing, and then find that it is coming from, or the virus is dummy. And same thing, the question can ask you, the virus is Smarty, can be fixed, cannot be fixed.
And so all we're going to do is just plug that into our equation, right?
And then you write the equation for the conditional probability or Bayes rule. Yeah. So again, the denominator, you have to work for the denominator. Numerator is straightforward, right? Not fixed and dummy, given that it is dummy. So work on that. And again, if you have any questions on that, send me an email. If you attempt it one time or twice and it's not making sense to you, just let us know. And also you can use your Math Help Center office hours. Ms. Minion will be there. And if you tried it 2 times and you have only one more attempt left and still not making sense, she'll be able to make you understand the question, or send me an email. Definitely, like, we cannot give you the answer, but we just don't want to leave it like this. So you can understand and then you can solve it. Same thing here, question number 18. You can make it a table and then you can work it. You can say there are 3 types: Democrat, Republican, others. So how many Democrats you have? So Democrats is 300 and Republican is 360 and this is 340. And then you can see favor, not favor, favor, not favor. And then you can do the same thing. And this one also, you can make a tree diagram, or if table works, you can do that. And it gives you straightforward what is the probability of C given B. So you need to find the probability of B first, and then probability of C. So work on that. And again, if you have any questions at any time, your homework is not due until tomorrow, and your quiz is not due until Friday. So we will have class on Friday too. So if you have any questions, we can go over with the homework questions on Friday as well. Thank you, everyone. And your test will be moved to Wednesday, and announcement will be sent to you guys. And see you guys on Friday. Thank you, everyone.
Thank you.